All right, everyone, let's go into the answer for this Chapter 4 problem section. I have comments on the Jupyter Notebooks, so I'm doing this all in Jupyter Notebooks. Maybe you should too, but you can do it in whatever you want. Okay, so this chapter problem, remember, we want to create a game, a guessing game number, or create a game of guess the number, basically, where the computer picks a number and then you have to guess it, all right? That's basically what it is. So we need to create a script that will ask the user how many times they would like to play, so they can guess, how many, maybe they guess like 3 numbers. Like, how many numbers do you want to guess is what we're asking with this. And then say for every game that they play, they need to guess between 1 and 25. We want to make sure that the computer tells the player if they were, higher or lower. So that way it makes it easier for them to guess. And when they guess right, we want to also record how many times it took for them to guess that number. Okay? So I'm going to just kind of move this. No, let's just go through it one line at a time. So we're going to import the random function here. Remember, we have to use that .randint. That should be also in previous stuff. You've probably seen this as well. You've seen us import, so you need to import that. The first thing we're going to do is create an empty variable, an empty string. We're going to call this games. And the reason for this is because we wanted to create this while loop with our input statement to find out how many games they want to play. Our first criteria here, how many numbers that they want to guess. Okay. Now we have our while loop here, and we have a try and except function going on here. So first thing that's going on is our while loop is keeping basically while our games variable is empty, it's going to continue to try and do this loop. And the loop it's doing is we're using try to try and convert the string response or the string return from the input function. If it can't do it, it arrows out like our last problem set. We have it print please select using a number, and we have it continue. Otherwise, the game's object will have something in it, and it will no longer be an empty string. Okay, so what ends up happening is if they continue to press the alphanumeric, anything but a number, it will get caught in this loop. It won't escape because we continue out of it, or we continue. Basically, it'll like reiterate back upon itself. Remember. So from there, once we have the number of games, we then use that range function from before. So we can go, for basically what this will end up doing is create a list of numbers between 0 and the amount that we pick. That'll still be like 5 games. We just count from 0, remember. And so if we put in 3 here, this range object is a list and has the numbers 0, 1, and 2. Okay, so game 0, game 1, game 2. And we don't actually use this game parameter anymore in the rest of this script. So it's not used at this point. You can maybe say like game 1 or game 2 if you wanted to provide additional information to your player, but otherwise we don't end up using this number for anything else for the rest of this game that we're making. The next thing we do is we use that randinteger function that I mentioned previously. So if we what this function does is it will select a number between two parameters, a start and end here. So what we're saying here is I want a random integer between 1 and 25. There are other parameters that you might be able to put into this, but this will give a 1 in 25 chance of any number between 1 and 25. Okay? And that's all it's doing. So the pick is like what number the computer picked. Okay? The next is what is the number that our user has guessed. And right now we're setting this as something called a none type. It's another data type, but it's basically a data type that says there's nothing in it. So it's designed to just like initialize a variable for information to come into it. So you could also have done none here and none here, and that would have worked just as well. Okay. And in some ways, this might be like very, very, very slightly more efficient because A non-data type object takes up less memory than a string type object. So if you think of it in those terms, that's actually an improvement. Anyway, back to this. We record the number of attempts. So we haven't even started the game yet. We just say we initialize it back to 0. So once this game is over, see how all of this is indented here. Once this indentation breaks and we move back into our next iteration, these variables are going to be reinitialized. So our number of attempts is going to be 0. So we got to make sure that by the end of this, this for loop, we print the attempts and that all of the guessing has already occurred and has been done. Okay. So what we now do is we have our pick and we have our guess. So if we think about the logic of how do we decide whether or not someone has guessed the number or it's too high or it's too low with these variables, we're probably going to want to pass, this guess object is going to be what we use our input function, almost like up here. We could essentially turn this into a function if we wanted to, because we're using it more than once and it might be useful. But regardless, we then run this here, which is basically, while pick is not guess, first what we're going to do, so basically what this logic is saying is if you don't pick the right number, right now, guess does not equal pick as we start the loop, so it's going to get caught in this infinite loop until that is the case, okay? So once we get into this is for the first time we pass this iteration, it's definitely not going to be, this is not going to be true because this is a number and this is none. The next thing we do is we try to update our guess variable to be an actual number by getting people to pick numbers. So this try and accept is similar to above, in that pick a number, and if they're not picking a number, they're typing something else in. It's going to just get caught in this infinite loop because guess is going to stay none, and we have this continue here. So if this errors out, it goes to this, and we have continue, and it never gets to this stuff. Okay? But let's say they do give a number. Okay. So if it's the actual number, by the time this whole thing returns back to here, it's going to break, and we should actually, if someone picks a number, we need to deal with all of the responses before this while loop is over. Especially because if it equals to it, then we haven't done our response to what the other numbers are. So how we then do this is we then build two if conditional statements. Actually, first one here should be, yep, that's all good. So how this works is if the guess is not equal to what the computer picked, the first thing we're going to do is count up. So count the number of attempts that are wrong because, okay, they guessed wrong, right? And we have our else statement here that I've spaced out a little bit. So let's just look at, this logic is going to take a little bit longer. So let's look at the else logic first. So if the guess doesn't equal what the computer picked, we're going to do a bunch of stuff. But if it did, we want it to respond, right? So we get it to respond. Hey, you got the answer right. This is how many times it took you. And this loop, this while loop, will now break because pick does equal guess. And we move into our for loop to run our next game. And then our picks and guesses are reinitialized and it starts all over again. So this is what happens when we get it right. But when we get it wrong, we need to have it do additional information. We have to do additional processing. We need to say why they got it wrong, basically. So how we do that is we first increment our number of attempts so that once we finally do get it right, it's recorded properly. And then otherwise, we need to run this if statement. Very simple. If the guess is too high, like a guess is greater than the number picked, we say too high. If guess is otherwise, it's going to be too low. And that's it, guys. This will run just fine like this. Let's just try ourselves. We're going to do one game first and then see if two games will work. So pick a number, 5, too low, 9, 12, 20, too low, 22, 24, 24, okay, and look, so it said you are correct, had the right amount of attempts, 1, 2, 3, 4, 5, oh, 6, so maybe we need to go, no, that's right, 5 attempts, oh yeah, a little bit of a bug there, so we can go attempts plus 1, and that will be right now. And then what else can we do? We need to then test, let's test 0, and then we'll test 2. How many games would you like to play? 0. And why did that fail? That's because we got a range between 0 and 0. So it's an empty list and it wouldn't iterate. Now let's just do 2, and you can see how it iterates across multiple games. So 15, too high, 10, too low, 12. Oh, I got it right, and the number of attempts was 3. And the reason why I needed to do +1, guys, is because when it was right, we didn't count that attempt. So we could do like this, attempts plus equals 1, and that just needs to happen every time, no matter what, because it was an attempt even if you got it right. That's why that happened, okay? So that's enough of a stress test of this code. So this is kind of the answer that I was hoping you'd find, or something close. This is probably all you need based on the knowledge that you learned throughout your chapter. So thank you very much, guys, and see you next time.